Who knows? There's no harm in trying. Back to the normal distribution. We said that we have two types of normal distribution. Standard normal and then the non-standard normal. The standard normal is denoted by a letter Z, right? And then the non-standard will be denoted by a letter X. How do we differentiate between the two? If a random variable is standard normal, the mean will be, what is the mean? 0. And the standard deviation is?
1.
Excellent. Anything different from that is?
0. Mean 0.
Anything different from 0 and 1 there is non-standard. So far, so good? Great. Now, since this is a continuous variable, we will be dealing with intervals. Continuous variable. So we'll be dealing with intervals. So we are going to learn how to find the probabilities associated with this standard normal. We will be using 3 rules. The first rule states that if you have probability of Z less than A, because it's continuous, you'll be using either less than or equal to. Less than A, which this is also the same as this, Z less than or equal to A. What do? You will look up the table. A good question will be which table, and I will give you the table in a second. Great. If you happen to have Z greater than A, which is the same as P of Z, greater than or equal to A, it will be 1 minus P of Z less than A. These are formulas. This is how we're going to find the probabilities when you happen to have a normal or a standard normal distribution. And the third one, if you happen to have an interval like that, this can be found by that. Now, because you are seeing Z all over, it means we are dealing with the standard normal. Does that make sense? This has nothing to do with the non-standard normal. We will get to the non-standard normal later, and then we know what to do with that. So the next, I guess the next step is distributing the tables. For those of you who already have the formula sheet, I think you should have these tables on your formula sheet somewhere. Welcome. So in a little while, we'll be talking about how to use these tables to find the probability. If you do not understand the table, make sure you ask somebody next to you to help you understand it. I'm going to do my best to help you, because there is no formula here. Everything is about the table. So if you don't know how to use the table, it means you're going to struggle. And you don't want to struggle. I wanted you to continue with that for me, yes. You didn't get one? No, it's over there. It's on your paper. No, what you holding? What you...
This is my chart.
Yeah, no, the tables are there. This is what I just gave to them. I gave them these two. Yeah, so you have it. Great. Now look at the table carefully. You have the positive z and the negative z. Make sure you have both. You have the positive and the negative. Yeah. Now that tells you that z can be positive and z can be negative. Is that okay? Great. Unfortunately, your tables, so I'm going to show you this. On the positive table, look at my positive table. Your diagram, the bell shape, is supposed to be shaded to the left, so make sure you do so on your paper. On the positive table, you have that. You have 0 somewhere here. And you have z over here, and everything is shaded to the left. So make sure that on the positive table, you have shaded that portion or that region. Does that make sense? This for the positive. And then on the negative table, it's just the last end. That is shaded. Do you have that shaded? Now let's try to understand why this is shaded. Now if you remember from 097, you did something called inequalities. Anytime you solve for x less than 4, you were asked to illustrate your answer on a number line. So assuming this is 0, 4 will be to the right of the 0, right? That is why you have a 0 over here, which is the mean, and z is over there. It means z is positive. Positive number is always to the right of the 0. And because it is less than, it is shaded to the left. That's what you did. You drew a little circle and then all the way to the left, right? So this shading portion is telling you, is an indication that you have less than. Of course, this is also less than, but this is negative because this z is to the left of that. You know, if this is the origin, all the numbers to the left are negative, right? That's why in the negative table you have this shaded. Meaning, every information you have in your table involves less than. It's either less than or equal to. Does that make sense? Meaning, again, that when you see a greater than sign, you cannot go here because there's nothing greater than on this table. That is why I give you these 3 rules or guidelines, whatever you want to call it. A, when z is less than a or less than or equal to, as long as you have the less than sign, you look at the table, go direct to the table and find the probability. I'm going to show you how to do it. But if you happen to have a greater than sign, you cannot read it from the table. So this is what you're going to do. You read the less than of that and take it from 1. Now it looks like you have variables. So we're going to work with numbers pretty soon because some of you, you're like, what is he talking about? That's okay. And then when you have an interval, you will read the bigger number first, followed by the second one, and then you find the difference between them. So with that being said, let's see if we can do some examples. And even before the examples, let's learn some few properties about the table. Now, if you look at the table carefully, on the positive, both negative and positive, you have the first column, which consists of 0.0 down to 3.4 or thereabout. And on top, you have 0 up to 0.09. Why this? What this means is any value associated with the z must be rounded to 2 decimal places. I'm telling you a lot of things. I'm giving you a lot of information. So make sure you get everything together. If you don't get it, just say, hey, I don't get it. We go over with you. But the good news is I haven't even done any example. So you can't say, I don't get it. All right. Great. For example, if you are asked to find this, find P of z less than 2.76. 1. Number 2, P of z less than or equal to 1.08. Number 3, probability of z greater than probably 2.14. How do we find this probability? Simple. You go to the table. But before we go to the table, we also want to learn how to graph this statement. You know, it's z less than 2.76. So that is a bell shape. What is the value at the center? 0, because this is z, right? If this is 0, where are we going to put 2.76? It's going to be somewhere here, right? And so we are looking for everything less than 2.76, right? So this is the diagram. Right? But then we want the probability of this using the table. Bless you. How do I go about that? Simple. Watch, don't go to the table yet. This is what you want to do. You are going to use the first 2 numbers. So we're kind of separating these 3 digits into 2. You split that into 2 using the first 2 and then the last one on top. So if I want to read this area, it will be 2.7 here. And then the 6 should be somewhere there, 0.6. That's how you split into 2. So you read it 2, and I believe you can tell me what number you find there. 0.9971. Do you all find 9971 on the table? Go to the table. You haven't checked the table, so you don't say no. So that is the probability associated with that. We are learning how to find the probabilities under normal distribution. That is all we're doing. Yes. Yeah, so that's the probability, yeah?
So that's
Wait.
Can you repeat why you went to 0.06 again on this part? I know you got 7.
2.7
Then why did you go?
is because we have the 6 over here.
Okay.
That 6 is what you have there.
Right. Okay.
Mm-hmm.
So that is always 2.
The first 2 digits,
Right.
the first 2 digits here, and then the last one, you find it on top.
My question is, it's always 2 decimal points.
Yes, it's always 2. If it's not, you may have to round it up to that, and we will get there. But for now, I'll be giving you everything rounded to 2 decimal places. Great. So the second one, how are we going to split it? 1.0 somewhere here, and then look for the 8, which is just before the 9. 0.88. Okay. All right. Is anybody here who can find that? Or one
Does it make any difference if it says?
less than or equal to? No.
Okay.
It's the same. That's why I think I said that this and that are the same.
Oh, right.
Great.
Are we always going to be graphing them as well?
Yeah, if possible. It's advisable. But is it necessary? But because I'm introducing it now, I want to get you into the habit of graphing it. And once you get to know how to do it, who cares whether you keep it or not? So far, so good?
Yeah.
Great. What if you have z greater than 2.14? You go to rule number 2. You know this is not less than, right? And you know that everything on this table is less than. So in order to do that question, you go to guideline 2, second rule, which states that we are going to read z of less than that number that is given to us and minus it from 1. Excellent. And we are taking it from 1 simply because of the greater than sign. So over here, how are we going to split this?
2.1.
So 2.1 under 4.
0.9838.
Oh, what are we doing with that 0.9838? Excellent. So do that so that we know the probability then. Wait, you don't get why?
Okay, so we're going to subtract 1 at the end after finding the answer.
After you find the answer, you deduct that from 1. You said point what?
Oh, okay.
No, the answer. 9838.
So it's 0.0162.
No, the table value.
Yeah, that's the difference.
That's it? Excellent. And why are we subtracting it from 1 again?
Because 1 is greater.
Because it is greater than. If it's less than, you read it, you keep it.
Oh, you read it like that, you don't find the result.
Results.
1 minus 0.938. No?
She's asking if you do it out, like if you got.
Oh, yes, you will. And you said that is 0.
0.162.
Okay, so that's the answer. Let's look at more examples. Yes, wait, hold on, don't lose.
So if z is less than 1,
Less than 1. Why are we using the 1? Okay, then. Uh-huh.
z is,
Less than.
okay.
And if it's less than, if z involves less than or equal to, you read it from the table, that's the end.
That's the probability.
That is the probability.
P-value, okay.
Excellent.
In this case, z
If it's greater than, you will read it, but you have to take it from 1 because it's the opposite of the less than. Awesome. Shoot.
Do we always graph before we do the calculation?
It's advisable to do so. Any other concerns? More examples then. Yes.
2.1. We just subtract.
So in all the
The
cases,
2.1
No, at the graph.
or the graph, we had 0.9838.
No, that is 2.14.
It's 2.14. So what you do, you split this into 2. 2.1 in the first column, and then the 4 is over there, 04. Awesome. Somebody was also, everybody okay? Let's continue with your examples. Let me know when you are comfortable, then I'll stop. Next example, find the probability of z less than negative 2.18. P of z greater than or equal to negative 3.14. P of z, now this time 1.09 less than z, less than or equal to 2.99. P of negative 2.13 less than or equal to c, less than or equal to negative 0.14. P of z greater than or equal to 2.76.
We're not that comfortable.
P of c greater than negative 1.38. So, give me the answer to this one. First, you can draw it. This is 0. Negative is going to be to the left of the 0, negative 2.18. and then you can shade it so you know the area you are looking for.
Do we have to do that?
Not necessarily, but you must know it.
But,
That-
but whether that number is positive, if it's a negative number, you're going to use your negative z-scores? Or
Yeah, if it's negative, you use the negative z-scores. That's why you have two of them. So what is the answer to this one?
0.146.
0.146?
You go to the negative table.
Like that?
Why?
Why?
Don't we go to like
Oh,
the
yeah,
negative
you're right,
table
I'm sorry.
because
I read it
it's,
wrong.
2.1.
No, it's not because it's 2.1.
0.146,
No, I'm
right?
Why do we go there? Why do we go to the negative?
Because it's minus.
It's because this is negative. That's what you meant?
Yeah.
Oh, okay.
I was just like taking out the 8 and then.
Is that okay? So if it's negative, you go to the negative table.
Yeah.
If it's positive, say on the positive table. You have that? Everybody okay with that number? Somebody needs help? Great. Let's continue. How about this one? Mm-hmm.
Why do we go to the negative table and the solution is not negative itself?
It's not negative what?
Like 0.
Because you are finding probability. Probability value is always between 0 and 1. Ah.
So you be 0.00081 minus.
So what do I do with that? Why should it be 1 minus?
Oh no.
Because z is greater than
Excellent. Because this is greater than.
Why don't you give us an exam on this tomorrow?
That is, he gets it. He gets this one.
I'll do well.
He's going to get 100 on that.
Give me 10 questions on this.
You get it. Thank you. All right. So this is greater than. So it must be 1 minus whatever you read from the table.
Which is 0.0008.
0.0008. And that will be 0.9.
9.
Excellent. Which is the same as about 99%, right? 99.9%. So they are not just decimals. This is almost 1. Now, the only example we haven't done so far is when you have two numbers.
Yeah.
But I think that is the third rule. The third rule stated that if you have two of these, first read the probability of the bigger number, that is the upper bound, and then the lower bound, and then you subtract them. But at first I would like to draw this.
So they both gonna go in the same graph?
Excellent. They're going to go on the same. So this is 0. 1.90 is supposed to be somewhere there, right? 2 point whatever is supposed to be here. So this is the area we are looking for. Looking for the area between these two. So in order to do that, we have to read 2.99. So somebody help me out. 0.99 minus. What about this one? 8621. So you're reading these two guys. The first or the bigger number first, followed by the smaller number, and then you find the difference between them, which is equal to 1365. So that is the area on that. Remember I mentioned on the first day that the area under the curve is equal to 1. Good. So just part of it is what we have here.
So you reverse them, you write the larger one first.
Yes, because it's always bigger than the smaller one. And I think we can try this too, yeah? So first, see if you can graph it. Remember the center is the mean, 0. Negative 0.14 is to the left of that, so negative 0.14. negative 2.13 is about somewhere there. So this is the area of interest. And to find the probability or the area of the shaded region, you will go to your Z tables. First, read negative 0.14. What is that? 0.5557. No. No. 0.1492. No, that is also no. 0.4. Minus what is the area under the negative 2.13?
Oh wait, so which two did you use? Which two are being used?
0170.
Which two are being used?
This one and that one.
Yeah, that's 0.01.
0.01 and negative 0.01.
0.014.
Like what, right here?
That's what I'm asking. Yeah, 0.01 and
4.
0.04. Okay.
Oh, okay.
Yeah, I was just confused.
All right, great. Great. Yeah, can I get this number again? Come on. Point,
166. 0166.
And so you can find the difference between them, right?
Yeah.
And then that will give you the area. Is everyone comfortable? When you have two numbers, the number on the right is always bigger than the one to the left. Yes.
You have an extra zero for the one before it. Yeah, because I'm going like a little bit slower than guys. Like the first, like, do you always subtract like the lowest number first? Because it's like backwards the way you did it. Like,
Yeah, you subtract the lower from the bigger.
okay. So just
But just make sure you don't subtract these two numbers. As long as you are not subtracting these two numbers, you're fine. So you can read this first, that second, then subtract the smaller one from the bigger one. Otherwise, if you decide to subtract this from this, you get a negative number, and probability cannot be less than 0. That's why you want to do the bigger one first. Is that okay? All right, last two examples. I'm going to add an alternative to the second rule. You remember the second rule, we stated that if it is greater than, right, you read it and subtract from 1. This is another way of going about it. So the kind of an or alternative. So let's do this first. So this will be 1 minus, can you read this from the table? Yeah, 2.76. So 2.7 under 6. 0.9971, which is the same as 0. Do you all have 0.0029? Yeah. Yeah, shoot.
Do you square root it?
No, there's no square root here.
Well, how are you getting 0.00?
It's because it's 1 minus
Okay,
that.
I was just looking as a part.
And why is it 1 minus this?
Sorry, I thought you were doing the other equation.
No, I haven't asked you any question. Why is it 1 minus that?
Because the 2.76, well, is smaller than the z.
No, that's not why. Why is it that?
Because it's the equation versus
Why are we not just keeping 0.9971?
because
Because
the 2.76 is less than
Z
z.
is less than the number.
She said it differently.
yeah, she put it the other way. That's great. If you know because it's because of the sign, I have no issue with that.
Oh.
Great. Now what we say now is, what if you do not want to do 1 minus? If you don't want to do 1 minus, it's as simple as this. When given probability of z greater than 2.76. You can change this to P of Z less than the opposite of this. What is the opposite of this? Negative 2.76. And when you read this, it must be the same as that.
Why would you do this again? Why would you?
So that you have different ways of doing it. So check this out and let's compare the answers. They are the same. Don't hate me yet. You can go out. All right.
That's the second time.
You need to arm yourself with all the skills and all the tools. Who knows? You may be tutoring. Yes.
The probability is what? Is it the mass that you shade?
The probability is the interval, that range, because it's a continuous data, between the two intervals. That is, if you have two of them.
Between Z and whatever the numerical value is.
So here, I'm looking for a better example. Over there is Z to negative infinity. It's an infinity. But then if you restrict yourself to this thing, then you know that you are playing under this curve. We're not going beyond that. So we say start from here up to wherever you are asked to do. So you are still under the curve.
So it'll never be a problem to do what you just did, just flipping it over.
Just flip it, make it negative, and you should be fine.
No problem with any other
That was my
questions.
question.
No.
So is it safe to say whenever you flip the sign, it's the same answer? Like,
We don't just flip the sign, we flip the sign and negate the number.
yeah, so it's the same answer, right?
What, it's the additive inverse, right? Would you call it additive?
Yes, it's the opposite.
Because it's the same distance from zero.
It's like a positive number when you bring it across.
So it becomes negative. Now, this is the reason why. I thought probably you will know, but it's as if you've forgotten everything you learned in pre-algebra, 097. You were told that when you have negative 3, x less than or equal to, or let's make it greater than or equal to 6, and you divide here by negative 3 and negative 3, what happens to this? Ah, that's what we just did. It flips, becomes negative 2. So if greater than, you flip it, becomes that. That's what just happened.
Yes, we have forgotten it.
Yeah, I know. Don't forget it. All right, so how will you go about this one? And make it positive. So you read positive 1.3 under 8. It's as simple as that. But if you don't like this, then you can go about 1 minus that. So far, so good. So now that we know how to handle the standard normal, we want to look at the non-standard normal, because almost all the questions you see in the homework is about non-standard normal. Non-standard normal. And the questions that will be on the test and the chapter 6 is also non-standard normal. Yeah, chapter 6 test. No. We are yet to take chapter 4 and part of chapter 5. Yeah, so chapter 6 after this test. Why are you so worried about test? Try to understand the material and forget about test. Yes. No, this is chapter 6. We are in chapter 6.
He's moving right along.
What did you just get rid of tests? No more tests?
We're done with 5. Chapter 5 was about probability distribution, that table, mean expectation, and then the binomial. That is chapter 5. Now we are in chapter 6. I started chapter 6 last week.
You did. I'm with you.
Yeah, I'm with you too. Thank you. Do I have to say chapter 6? I don't have to. It's a new material. Most important thing is, do you understand it? Yes. Yay. All right. So, since we have two types of normal distribution and we've covered one part, let's look at the other side, which is the non-standard normal. Non-standard normal, which is denoted by letter X. How do we find probabilities associated with that? Simple. Since we do not have a table for the non-standard normal, but the standard normal, anytime we get any random variable that is non-standard, we will convert it. We will change it to standard normal. If we are going to change it, then we need a conversion formula. How to change X to Z. Because anytime it's changed to Z, everybody knows how to find the probability from the table. Right? So we will start with what we call conversion formula. And we are converting non-standard normal to standard normal. How do we do that? I'll first write that in English because some of you appreciate that before I give you the statistical symbols. So Z, if you have X and you want to change X to Z, you will subtract the mean and divide by the standard deviation. Yeah, again. These two guys.
These are the same
They-
mean and standard deviation that we've been dealing with all along.
Yes. Which will be given to you. I told you last week that as long as you are told that you have a normal distribution, then these two parameters cannot be missing. Because without these two, it ceases to be a normal distribution. And I gave you some funny examples like, hey, or maybe I did not, maybe the other class. Hey, I have a car. Oh, but my car doesn't have an engine. It's not a car. Throw it away. So, hey, I have a normal distribution, but there's no mean and standard deviation. It is not a normal distribution. Great. Oh, I have an iPhone, but it doesn't work. It doesn't have a screen. Throw it away. Great. Now, statistically, this is written as X minus our dear friend mu divided by sigma. That's simple. Oh, this is supposed to be Z, sorry. This is supposed to be Z. Come again? Oh, that's sigma. It's the same as the standard deviation. And that is how you convert X to Z. And that's the only conversion you have to make. So I think we have time. So I would like to do just a single example. And then we can talk about the midterm. Sorry, the next test.
We haven't even taken this and we're already talking about the other one.
Oh my god.
And then you ask us why we're stressed out? Yeah.
Oh, it's right here.
Why don't we talk about the next test after
Oh, let's talk about the test on Thursday.
Oh, that's what he means.
Why don't we talk
Why
why
don't
don't
we
we
talk
talk
about
Thursday
it
test?
Tuesday? Because we have the test on Thursday.
No, he wants,
Today is Tuesday.
Tuesday is Tuesday.
2 days from today is Thursday.
he wants to talk about the one on Thursday.
Oh, you want to talk about the one?
Yes, madam.
Oh, I thought you talking about.
You see, you're already stressed out. I told you guys, you worry so much about X.
Well, you know reason why.
Oh.
And after that, simplify it at the end when we try to understand the complicated part.
Oh my.
It's messed up.
But don't you like statistics? You love it. We don't just write numbers, we think about the numbers.
Yeah. You just confuse your brain. When we try to understand the complicated part, you just be like, oh, okay, you can do it that easy way too. We're like, really? Why didn't you just say it at first to make it easy for everyone?
It's good to know all of them. Otherwise, you'll be a handicapped statistician. Oh, yeah, I did statistics. What do you know? I don't know nothing. Like, what? Then you didn't take statistics? And the sad part will be, who taught you statistics? Francis.
No, we just feel like, give me a table and I'll tell you.
I'll tell them something about your table.
Give me a table and I'll
All right. So, chapter 6. All right. So, let's do this and then. Trying to get just a simple example to illustrate. Earthquake, aircraft, cobalt, da da da. Yes, good job, good one. Great. Let me start from here because I think you may have something similar to that on the homework. I think I like to keep this. All right, so here we are in exercise 5 to 8. Find the area of the shaded region, that is the probability. The graph depicts IQ scores of adults, and those scores are normally distributed. As soon as they tell you it's normally distributed, the next thing that must follow is the mean and the standard deviation. So you read a question, you read anything involving normal distribution, anything that tells you that this is a normally distributed information, make sure that you find the mean and standard deviation. Because without these two parameters, it's not normal. Great, so the mean is, and the standard deviation is? Great, so here you are asked to find the area under this. Would this be less than or greater than? Why is this less than? Because it's shaded to the left, right? So it shows it's less than. How about this one? It's greater than. And everybody knows how to play around with the greater than, right? So assuming we have to find the probability involving this. Because you said it's less than, I'm going to use x less than or equal to 118. Why can't I use z here?
Because it's not normal.
How do I know it's a non-standard normal?
Because it's X.
No. From this information.
Not equal to 0.
Because the mean is not 0 and the standard deviation is not 1. So nobody's going to tell you this is non-standard. You have to see it and convince yourself, this is X. When the mean is 0 and this is 1, this is Z. Does that make sense? Great. Now, since this is X, what do we have to do? Convert it to Z. How do we convert it to Z?
X minus the mean divided
So this is your X 118, so minus,
the mean
which is
100
100 divided by
15.
excellent. So this is Z less than or equal to now your calculator, 1.2.
Yep.
But can I write just 1.2? What do I have to do?
Round up to get like 2 decimal.
Excellent. So how do I make this 2 decimal? Put a 0. Otherwise, when you go to the table, you'll be like, how do I find it? So whenever you have X, to change it from X to Z, subtract the mean from the number and divide by standard deviation. That is the formula over there. And then from here, who doesn't know how to use Z? Now I've taught you how to do that. You go to the table and then you have 1.2 under 0. What is it? 0.8849. So this is about 88%. And this is how you interpret this. Remember, this is about adult IQ, right? So what we're saying is about 88% of adult IQ. R is less than that. Yeah, now because we add in flesh, because first it was just Z. What is Z? Who cares? But now that we add in a little bit of the non-standard, it's now becoming more understandable. Number 6. Which inequality should I use? Greater than. Why the greater than? Because it's shaded to the right. That's very, very important. So, what do I do from here? Convert it to Z. How do I convert this to Z? 91 minus the mean, which is 100. P of Z greater than or equal to? Negative 0.6. 0. What is the probability from here? What can we do?
Oh, use a positive table because it's C is greater.
Can you flip it and make it positive?
Why can we do that?
Because Z is greater.
Because it's greater than. Don't forget these rules. So this is that. Now you can read it from the positive side. All right. So we will continue from here next Tuesday.
So we done?
Because on Thursday, yeah, I'm done for the day.
Oh, really? Wow.
On Thursday,
We have a survey to do.
we have a test.